Okay, so in this proof, we're going to prove something that you've known for a long time, but you've probably never seen any proof of it. And that is the triangle angle sum theorem, which states that the sum of the angles of a triangle is 180 degrees. Okay, so we've got this image here that's clearly got a triangle in it with your three angles. We don't know anything else about those angles other than we know from our time in middle school that they do add up to 180 degrees. But notice they've drawn this line here. There is one line that you can draw that connects to a vertex of a triangle that is going to be parallel to the opposite side of that vertex. So that line's been drawn for us here, and it's already been labeled as being parallel. So that's one of the givens, is that this line AD is parallel to BC, and we've already got it labeled on the figure. Well, think about what we can know from having a set of parallel lines. If I have a set of parallel lines and I've got this line going through it, I don't know about you guys, but it helps me if I kind of extend this line out so that it looks more like a normal parallel line set. So when I do that, this is clearly a transversal, which means that angle 1 and angle 4 are alternate interior angles. We know that that means they're congruent. I also have another transversal here with sets of alternate interior angles and consecutive angles and all sorts of things. So if I have this transversal, then I know that angle 2 and angle 5 are also going to be congruent. So I've got a lot to work with here just based off of the picture. So let's see how we might be able to use that to get from just this picture to a solid proof that the measures of these three angles do in fact add up to 380. All right, so again, think about what we know. I'm going to go ahead and put down the given here because that is going to be crucial to this, is that I have a set of parallel lines that are cut by transversals, and that's given to me. Okay, so we already kind of pre-talked about some important stuff that we get from the fact that we have parallel lines, and that is that angle 1 and angle 4 are congruent because they're alternate interior, and also angle 2 and angle 5. Remember that if the reason is the same, then you can put that as part of the same step. You can say, this is just one step. I know that these pairs of angles are congruent because they're all alternate interior angles. So they match the criteria for that theorem. Okay, well, if I know that it's congruent, remember from the last video that I did, I pointed out the difference between just congruence and equality and the measures being equal. I know I'm going to need to move towards talking about measures, so I'm going to go ahead now and use that definition of congruence from before to transition from angle 1 is congruent to angle 4 to measure of angle 1 is equal to measure of angle 4. And again, I can combine both of those in one step because it's the same reason. So I'm just going to do them both at the same time. Now, that's all well and good. How is that going to help me prove that these three angles add up to 180? Well, again, I've got to start thinking in terms of what do I know is supplementary. Well, I know that linear, or that anything that makes a straight angle adds up to 180 because the measure of a straight angle is 180. So if I look at these three angles, they're not technically a linear pair because there's more than just a pair of them. But I do have three angles that when all combined give me 180. So that's probably going to be important. So I'm going to say the measure of angle 4 plus the measure of angle 3, plus the measure of angle 5, all add up to 180. And the reason I would put there is that they form a straight angle, and that's the definition of a straight angle. So it's kind of a dual reason. You've got to cover both pieces of information there. Okay, well, now I know that the measure of angle 4 is equal to the measure of angle 1. So I could do some substitution there. I know that the measure of angle 5 is equal to the measure of angle 2, so I could do some substitution there, and that's going to get me the three pieces of information I actually need. So I'm going to go ahead then and do that substitution, and my reason, of course, is just the substitution property of equality. Again, that's an algebraic thing that you've known for a long time. Now, there's one step left here, you'll notice, and there's one little thing that's off. In my proof, I'm asked to prove that measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 is 180. And it looks to me like I've done that, except I've got a little order issue here. So again, this is semantics and it's a little nuanced, but we have another property that says I can change the order of addition problems whenever I want. So I'm going to go ahead and do that, and the reason I'm allowed to do that is because of my commutative property of equality, or you could say the commutative property of addition, because I'm changing the order of an addition problem. And now my final line looks exactly like the thing I was asked to prove, and I'm finished. So now you've had an official proof of the fact that triangles, the sum of their angles adds up to 180, which means now you can use it in whatever proofs you want. All right, you've got one more proof left to do, and then you can go enjoy your day off of school. See you in class. Bye.